Okay, so picking up where we left off, we've got our transformations of trigonometric functions the same as any other function. So vertical dilation, horizontal translation, and vertical translation, making sure that you get these in the right order. So this one is a translation first and then a dilation. That changes if you put brackets in here. Okay, so let's have a quick look here. We've got a graph of y equals 3 sine 2t. Okay, so you'll see that this sometimes it's t, sometimes it's x, sometimes it's theta. Just work with whatever you're given. Okay, so this is our vertical dilation, so we've stretched it. Okay, and you can see that that's changed the amplitude to 3. So this affects amplitude. Okay. As for this here is your horizontal dilation, and that affects your period of the function. Okay, so when you squish it in, so remember that's a factor of a half, okay, because it's the inverse. So you've squished it in, made everything half the distance from the y-axis, so instead of having a period of 2 pi, we've got a period of pi here. Okay, so you'd go like that, and you'd fit another one in up to 2 pi. Okay, so that affects the period. So if you can sort of get your head around what transformation affects what part of the graph, that makes it a lot easier. Okay, so state the amplitude of each of the following. So your basic y equals sine x, obviously your amplitude is going to be just 1. Okay, when it's 2 cos x, it doesn't matter whether it's cos or sine. It's much the same. So the amplitude here, we've got a dilation factor of 2, so that's just going to be 2. And this one is going to be amplitude of 4. So pretty straightforward there. So you can actually see, you can read the amplitude straight off the equation of the function. Okay, next one. So we're looking at a period now. So again, basic function there. Period's going to be 2 pi, or it's asked in degrees, so degrees, 360 degrees. Okay, this one, remember tan is different. Tan is 180, so it's still going to be 180. Okay, now this one here, the only transformation we've done on it is a vertical dilation. Now the vertical dilation is stretching, so it's going this way, stretching up or down. That doesn't affect the period, so this is still going to be 360. Okay, so working in this direction doesn't affect the period, which is horizontal. Okay, and for this one, we've got an equation. We've been told that it's in the form of y equals a cos bx. One thing you'll realise sort of fairly quickly with trig functions is that you can make them up in all sorts of ways. It could be a sine function or it could be a cos function, depending on whether you give it a phase shift or not. You can do a phase shift instead of a reflection. Okay, so if you're told what the form of the function is, then you need to work that out. But if you're not, then there's sort of many valid answers. So we try to be a little bit more specific with the questions to make sure that we give you some guidance on what it looks like. So this one we're told is a cos function. Okay, so the first thing we need to look at is the amplitude, where you can see it goes from minus 3 to 3. So the amplitude's got to be 3. Okay, so that's a difference of 6, and half of that is 3. We can have a look at the phase. Okay, so we're going one complete cycle. The phase is 180, so we know that there's got to be a horizontal dilation there. Okay, we've squished it in. Also, one thing you need to notice is that we're starting down the bottom here. Usually cos function starts at the top, so that's been reflected about the x-axis. So there's also a reflection about x, which of course is where we put our negative at the front. So therefore, your graph is going to be minus 3 cos and 2 x there, because we've got a phase, so that's not phase, that's period. We've got a period of 180 instead of 360. Okay, so that's how we work out our equations for the graphs there. Alright, so in summary, the unit circle generates the graph of a trig function. If you ever get stuck, go back and have a look at one of the animations. There's hundreds of them out there. I like GeoGebra because you can toggle with your slider here and see what's going on. Okay, so that makes it nice and visual. But do go back and have a look at those if you're sort of not sure. Remembering the amplitude is the distance from the mean of the function to the minimum or the maximum, okay, or half the distance from the minimum to the maximum. That comes in handy when you start doing vertical translations. The period is the time taken for one cycle, okay, measured in radians or degrees, but do get used to using radians. And then you've got your transformations where the vertical dilation affects the amplitude, the vertical translation affects the position as the maximum or minimum. So what that means is you might end up with a function that's up here, okay, instead of down here, because you've done a vertical translation. Your horizontal dilation affects the period, so how many cycles can you fit in that 2 pi, or how long does it take for a cycle, and the horizontal translation affects the phase, or the y-intercept. So what point actually occurs at y? Is it 1? Is it 0? Is it somewhere in between? So that's where we start talking about phase shifts, okay, and whether we can map cos x onto sin x.